So let's use some coordinates for this problem. So the length of a rectangle is 5 and width is 4. So if we make the coordinate, I'm going to put the point D at the origin. So A's coordinates are 0 and 4, and C's coordinates are 5 and 0. And B's coordinates are 5 and 4. And because the length of EB is 1, that means what will be the coordinates for E? At this point, it's like 4 and 4, right? Because we subtract 1 from 5. Like this. And CG, the length of CG is 1, so what will be the coordinate for G? Uh, 5 and 1, because it's 1 unit up, G. And point F lies on CD, and DF is 2. Yep, so what's the coordinate for F? So 2 and 0. Yeah, 2 and 0. And segment AG and segment AC. Yeah, and then let's make the equation for line for segment AG. So for segment AG, the slope is 5 and 3 and the negative. So yep, this is the equation for segment AG. And segment AC, slope is minus 4 over 5. And for segment EF, FE, slope is 2. So using these equations, we can find the coordinates for the P and Q, the intersection point. So to find the coordinate of Q, the first and third equation we are going to solve. So, so let's so Q's x coordinate is 40 over 13. y coordinate. Yeah, I think x coordinate is enough. So yep, q's x coordinate is 40 over 13. And to find the p's x coordinate, when you solve the third and second equation, oh, am I right? A then 2.8, 2.8. Oh, something. Okay. So that means for the length of PQ, uh, I'm going to just compare the x coordinates. So the horizontal distance between P and Q is if we subtract these x coordinates. Okay. And then EF, the x coordinate is 2. So if we divide this by 2, the answer is D. So because EF coordinate is 2, the ratio is 10 over 91. In number 20, let's make some graph using decimals. So the first circle, the center is 2 and 2 and radius is 2. That means we can make the equation for the circle. Yep, so this is one circle. And when it's dilated, and new center is 5 and 6, and radius is 3. Yep, so when we make this dilation, question is the origin move to which point, and what's the distance between the origin and the due point. So if we use this graph, the origin is here, so that means the dilation may move this origin to this point. Because when you think of these lines, they are both the tangent to the circle. What's the coordinate of this point? Your coordinate? Yeah, 2 and 3. So that means what's the distance from the origin to the point 2 and 3 when you use Pythagorean theorem? So what's the length of this? Yep. So the answer is C. Once again, let's use Desmos to find this graph. I mean, we need to solve this by hand, but I'll just use Desmos for the better visualization. Yeah, so this type of graph, we wanna find the area. So I think we can make this square inside the graph. So what's the side length of this square? Yeah, yes, square root 2. So that means the square's area is 2, and then how can I say? So the radius of this the 4 semicircles, because diameter is square root of 2, the radius is 1 over square root of 2. That means the area of this semicircle is like this. Am I right? Pi r squared 1 over 2 divided by, okay. So the inside the square's area is 2, and because there are 4 semicircles, if we multiply 4, that becomes just pi. So 2 plus pi is the area. And in number 22, so every team won 10 games and lost 10 games. So that means in this tournament there are 21 teams, because each team play 20 games, so including itself, the total there are 21 teams. So if we follow this order, A beat B, B beat C, and C beat A. So there will be 10 teams beaten by A. So let's say the 10 teams are B1 to B10. And then there will be also 10 teams which beat A, and the teams, there will be 10 teams, so we can say the 10 teams are from C1 to C10. So if we want to make the cycle, so let's start from B1. B1 B1 also will play all the other teams, and let's say this B1 wins all the Bs. That means B1 is a 9 win. So to make 10 wins, B1 needs to win one of these Cs. So we can make the triple like this. So now A wins B, and B wins C, and C wins A. So if B1 wins 9 times within this group, there will be one loop for B1. And let's go to B2. And because B2 is lost by B1, the maximum number of win within this group for B2 is 8. So, but B2 also needs to win these 10 games. So that means B2 needs to win B2 teams in the C League. So in such case, we can make these loops two ways. So there will be 2 loops. Or so we can decrease for the wins for B like this. But in such case, we can increase the loop for C. So when this trend continues, B10 will have 0 wins among the group B. That means B10 should win all the Cs, because every team won 10 games. So if B10 beats every team C, we can make 10 loops. So for the number of loops, we can add 1 through 10. So what's the sum of 1 through 10? Yep. Yeah, 55. So for team A, we can make this 55 loops, and there are total 21 team. So we can make these loops for each team, and each team will have this 55 loops, because every team won 10 games and lost 10 games. So 55 times 21, but for one loop, the it's counted 3 times, because we are looking at for the perspective of A, or for the perspective of B or perspective of C, so we need to divide this by 3. So that means it's like 55 times 7. So from the choice, which one is the product of 55 and 7? Yeah, can you multiply 55 and 7? Yep, so the choice is A. And in number 23, there is a regular hexagon. So if there is a regular hexagon, and there are 4 additional points, W, X, Y, Z. Like this. And these lines are parallel and equally spaced. So that means if we make the altitude of this triangle, the ratio between these two is 2 to 1, because if we connect the other triangle like this, now they are equally spaced. All the distance width is 2 between these 4 lines. And then let's make one triangle on top of uh, the hexagon. And because this red triangle is congruent to one of these 6 triangle, we can say the altitude is 3, the sum of 2 and 1. So that means, so if the vertex is G, the ratio of similarity between GBA and GWZ is the same as the ratio of on this altitude 3 to 5. The total altitude is 5. And in terms of area, if the scale factor is 3 to 5, for the area we need to square. So the ratio between area is 3 squared to 5 squared. So 9 to 25. That means so let's say the area of this GBA is 9A. In such case, the area of the trapezoid ABWZ is 16A, so that the area of GWZ is 25A to make the ratio of the 3 squared to 5 squared. And the area of the big trapezoid ABCF is 27A because this the trapezoid ABCF is made of 3 triangles, and each triangle's area is 9A. So the big trapezoid area is 27A, and if we subtract this small trapezoid 16A, that means the bottom layer's area is 11A. So in such case, the middle hexagon's area, this area is 11 times 2, so 22A over the area of the original hexagon is 9A times 6. So we can cancel A, and if we simplify 22 and 6, so now what's the ratio between small hexagon and original hexagon? So the numerator is 11, the denominator is 9 times 3, 27, so the answer is C. Yep, in number 24, there are two inequalities. AB is less than BC, and BC is less than CD. And these three terms make the arithmetic sequence. That means the middle term is the average of the first and third term. So if we make the equation using the property of arithmetic sequence, the 2 times BC is equal to the sum of A, B, and CD. And for the 10th digit, we need to multiply 10. So this is equal to so we can make this equation, and if we open the parentheses and move the terms, we can simplify the equation, and because A is not 0, if A is 1 and if B is 1, A should be also 1, but all things become 1, so that does not satisfy the inequality. So this means B cannot be 1. We can start from B with 1, so that means let's start with number 2 for B. So this means 19 times 2 is 38. So because of this increasing order, A should be less than B. So A is 1. So if B is 2 and A is 1, what will be the value of C and D satisfying this equation? Yep. Uh, 28, because 19 times 2 is 38. 38 minus 10 is 28. So that means, let's say C is 3 and D is 4. So now the 8 times 3 plus 4 is 28. So this is one example, one quadruplet we made. Or yep. And then let's increase the value of B to 3. And if A is 2, now what's the value for AC plus D? Uh, if you subtract this 10 times 2 from 19 times 3, yep, so 19 times 3 is 57, so minus 20 is 37. So can you think of a value of C and D making the 37? AC plus D is 37. Yeah, yep, AC plus D is 37. So so you can actually divide the 37 by 8. Yep. 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 Yeah, something like this, right? Yep. So that's another the quadruplet. And then we can decrease the value of A to 1 when B is 3. Now what will be the value of C and D? Yep. So now AC plus D is 47 instead of 37. Yep. So yep. So that's another case. That's enough for 3. So let's increase the value of B to 4. And then A should be less than B, so A is 3. In such case, what will be the value of C and D? Yeah, B is 4 and A is 3, so C and D should be satisfying this equation. So 19, yep, 19, yes. Yeah, and so 19 times 4 minus 10 times 3. Okay, so can you see the screen? I mean, 19 times 4 minus 10 times 3. That will be the, yep. You're right. Yep. Yep. So let's decrease the value of A to 2. So I'm going to write here on the right. So if B is 4 and A is 2, what will be the value of C and D? Let me write like this. Yep, that's possible. That's one case. And if the value of d mm, is zero or less than two, in such case we can give one value of c to d. What I mean is, we can also make this type. So by increasing d to 8, the value of c is decreased by 1. So we can make two cases in this case. And then how about the value of a is 1 when b is 4? What are, yep. So I think that's enough for the number 4 in b. So let's increase the value of b to 5. And a starts from 4. So now what's the value of c and d? Yep. Yep. How about 5 and 3? B is 5 and A is 3. Yeah, 8 and 1. 8 and 1. So if like this, I mean, the when the value of D is less than 2, we can add 8 by borrowing 1 from C. So we can make two cases. That means now D is 9 and C is 7. That's also possible. Yeah. And then how about 5 and 2? B is 5 and A is 2. Yep. Yeah, 9 and 3, am I right? 95 is 75, so we have 9 and 3. So, and then I don't think 5 and 1 is possible. So 95 minus 10 is 85, but AC plus D uh, cannot make 85. So we don't have to think about 5 and 1. So that's enough for number 5 in B. So let's increase the value of B to 6, and A starts from 5. Yep, now what's the value of C and D? Yep. Yep, 8 and 0. And because the value of D is less than 2, we can borrow 1 from C. So that means another quadruplet is possible. How about 6 and 4? B is 6 and A is 4. Yeah, 9 and 2. And I don't think we can make 6 and 3 because that should be AC plus D is 84, but that's not possible. So that's enough for number 6 in B. So let's increase the value of B to 7 and A is 6. Yep, so what's the value of C and D? Nine and one, and because the D is less than two, we can borrow C from. So that means another case is possible, like this. And uh, the last case is when B is 8. B is 8. Usually, A cannot be equal to B. So, I mean, so if B and A are both 8, what will be the value of C and D if B is 8 and A is also 8? That means AC plus D should be 72. So can you think of C and D making 72? Yeah, yeah, 990. 72 means 8 times 9 is 72. So that's we can make one case for B is 8 and 8 and 7. And we cannot even make this 8 and 7. Now the difference become 2b. So these are all the cases. So how many cases did we make? Uh, can you count these how many quadruplets are here? Yeah, everyone. I mean one, 1, 2 like this. Yeah, 17. So there are 17 cases satisfying this inequality, and the sequence is arithmetic. And the last problem, we are using the greatest integer function. It's also called the floor function. So we can think of number x uh, to the integer part and the remaining part. In this case, the remaining part is between 0 and 1. In such case, this floor of x, it takes only an integer part, so this floor of x is just n. So if we change x to these symbols, f of x is the first floor function. When we multiply k to x, and then for the second floor function, k times this floor of x is n, so the second term is k times n. An important property in this is because k times n is integer, this because k is integer and n is also integer, so k times n is also an integer. So when there is an integer in the flow function, we can take the integer just out of the flow function. So that means we can take this kn out of the flow function, and the remaining term will be still be in the flow function. So after taking out, we can cancel this kn, and so only the flow of k alpha remains. And if we open this sigma notation, this means the first term is 2 times alpha, the floor of 2 times alpha, like this, and this will go up to 10 times alpha. And for this sum to have the distinct value, if one of these flow function becomes integer, if any value inside this flow function is integer, that will add uh, integer 1 to the sum, so that will make the value distinctive. So uh, uh, the lowest value for alpha is 0. When alpha is 0, all the values become 0, so f of x is 0. That's one value. And then let's start with this 10 times alpha. To make this 10 times alpha integer, alpha should be 1 over 10 and 2 over 10. 2 over 10 simplified is 1 over 5. So we can increase the numerator by 1. Yeah, so these are the values which make this 10 times alpha integer. And then next one is 9 times alpha. So for 9 times alpha to be integer, alpha should be 1/9. Yeah, so these are the values of alpha which make 9 alpha 0. And how about 8 alpha? 8 times alpha to be integer. This 4 over 8 is equal to 1 over 2. It's already counted, so we should not include the 4 over 8 again. And the next one is 7 times alpha. And next one is the 6 times alpha. And 2/6 is 1/3. 1/3 is already here, so we don't have to include the 2 over 6 twice. And 3 over 6. 3/6 is half. Half is already included, so I'm not going to write 3/6 twice. And 4/6 is 2/3. 2/3 is already included. So the next one is the 5/6. So when the denominator is 6, there are only 2 fractions. And how about 5 times alpha? 5 times alpha to be integer, uh, the fraction will be from 1/5 to 4/5, but they are already included here. They are already included when the denominator is 10, so we don't have to think of the 5 times alpha. 4 times alpha is the same. I mean, 1/4 and 2/4 and 3/4, they are all included. So for the rest of the fraction, they are already included here. So these are all the fractions which make the sum of these flow function have a distinct value. So can you count all these fractions? How many numbers are in the list? Yeah, yeah, including zero. So first row is 10. Like this. 32. Yeah, 32. Yep. So the answer is A. Yep. So that was for this 2006 AIMS 10B. So we can move to 2015.